And I'll post a schedule soon. Okay, so today I want to talk about lab reports in general and then lab reports specific. I need to step back because who was in 120 in the fall? You guys were in 120 in the fall and Rosa. Okay, so you guys did not even get to talk about lab reports at all. So, so those of you guys that are seniors and written lab reports for years, this is going to be kind of old hat. But I do think it is. I do think it's worth to stop and think about what goes into a lab report. I'm sure you're probably not done writing lab reports. If you're going to grad school, I'm sure you probably have to write them. I mean, when I publish a paper, it's basically a lab report. It's the same exact format that you guys will use for your lab report. Okay, so it's unavoidable. And actually, the way that it's formatted, it's taken probably hundreds of years of fine tuning to get this format down just right. Okay, and it fits with the scientific method, right? Because what do you guys know? Like, what are the? I'm not talking about observation, hypothesis. What do you know about the scientific methods? What are some of the basic tenets of it? What are some important aspects of science? Science needs to be these things to work. Right? And I think this has come in really clear focus this year because we really have leaned on science for our personal health and safety, right? And scientists have been in new light, I feel like. I don't know, that's how I feel at least. I feel like people are tired of listening to politicians tell us how to deal with this deadly virus, and they're sort of like, can we hear from the scientists, right? But what are the aspects of the scientific? I'll tell you, one of them is science needs to be transparent, right? Which means we need to be able to see where the data is coming from. Actually, just AstraZeneca came out with their big results. I think it was on Monday that their trials from the United States. And at first, what did they say? 79% accuracy. But then the scientists were like, wait a minute, you're using the wrong data. You're using outdated data. And just this morning, they adjusted that to 76%, right? If science this was not a transparent process, they can't be held accountable. And it's too much to ask to just trust us. No, we need to be able to pull back the curtain and see, how did you come up with 79%? Oh, that's bullshit, right? We need to be able to have that aspect. It needs to be repeatable. There's a lot of things that science needs to be. And so when we talk about how science, there's another big thing. Science is, I like to think of it as an iterative process. Okay. It's all about finding an answer. It's all about finding the truth, if you will say, or the answer, right? And we get close sometimes. We never know if we're exactly at the answer. Science never proves anything, okay? That's an important point. A lot of people will say, well, why should I wear a mask? It hasn't been proven that it reduces transmission. Have you heard this type of language, people saying this? Well, no, but the evidence, all of the evidence suggests that masks, when worn properly, reduce transmission, okay? And so we start out maybe way over here at an answer, and then we keep getting closer and closer and closer and closer. This is how I think of science, right? We're not quite sure when we've got there to exactly the truth. And it's usually one person doesn't start way over here and get to the middle. One person might start here, and then their investigation ends here, and then another group comes along, and then they use what the other researchers have done. They capitalize on the insight gained by this group of researchers, and they move the ball forward to here. Or you can think of it as like a football field, right? These guys get first down, maybe they, whatever. But unless you communicate your results in a standardized fashion, then people can't, they're always trying to reinvent the wheel, right? Scientists are always just trying to redo things that somebody else did. That's the importance of lab reports and scientific publications, right? Is that it helps us to communicate how far we brought this to an answer, okay? And I'll touch back on these things, but this is the basic format of your lab report too. These are the sections that you're going to have. Introduction, the results, no, methods. And I'm going to just give you real basics about what goes in each of these sections, and then I'm going to show you more specifically our lab report for this semester. It's often called IMAD. IMAD. Intro, methods, results, and discussion. Okay. So it all starts with a question. We said we have a question. The introduction, it introduces the question. Right? It tells the reader what question, the research question, are we setting out to answer. Okay. That's pretty basic. Right up front. Otherwise, you might not want to read this paper because we're talking about logs and wildlife and or COVID and transmission or whatever, right? This is just a statement of our goals. It provides background that includes previous research. Okay? This goes back to this iterative process. If you're starting here, you're going to tell us a little bit about how we got to this point, right? Rarely do we start some investigation where we don't know something. We're always picking up where somebody left off. That comes in the form of literature. Right? We're going to provide citations to previous literature that investigates the same question. Okay. We are going to provide an impetus. Anybody know what that word means? Impetus, not impotent. Impetus. Impetus. What does that mean? What is the impetus? What's your impetus for being here this morning? This is like the justification or the reason. Okay? This is telling the reader why this is an important question. You're sort of justifying you setting out to spend money and resources to answer the question. You're providing, basically, you're telling the reader, why is this question important? It's got to be there. We don't want scientists going out and investigating stuff that's just, there's so many problems in this world that we need people spending their time answering those important questions. Okay. And the other thing, big thing that we do in the introduction is we sort of take a stab at an answer. Answer to what? Answer to the question. Okay. And what's this called? That call when we're starting out at the beginning, we have not collected any data, we don't have any evidence, but we have an inkling about using our logic, using reason, using what's already known, using literature. We're going to start out with what we think the answer is going to be. That's the hypothesis. Yep. And a prediction based on the hypothesis. I'll talk about this during this presentation. This one's really important too. So that's basically your introduction to your lab report. Probably the longest part of your lab report because I want you to get into a little bit of literature. Maybe 2 pages. The whole lab report should be like probably 5 pages. It's not a huge assignment. This is not a 20-page assignment. Okay. The bulk is going to be here in the intro, again, just because I want you, if you are serious about science, get into scientific literature. Something somebody told me in my undergrad, and it has proven to be very, very true. If you want to learn what's going on, if you want to learn, if you're a physical therapist and you want to know the newest way to treat, what was that, Tommy Johns or whatever, you go to literature, right? That's the cutting edge. You can go to Google Earth right now or Google Scholar and find things that were published last week about COVID. It has not made it to Science Daily yet, right? This is how things are done. Method section, this one's relatively simple. We're going to tell the reader what you did. Okay. Such that someone else can repeat your experiment. This goes back to that transparency, okay? This goes back to the transparency. If somebody publishes a paper and says that vaccines can lead to autism, well, that's a big deal, right? And do you guys know this whole story about somebody did that? Published it in the British Journal The Lancet.
Wasn't it a lie?
People said, really, we've been doing this for a long time. You think we would know about this? So what do? They go straight to the method section. They look and see, what did this guy do? How did he come up with his answer? How did he come up with his answer? They look at his methods. They try to repeat them. I don't think so. Try to repeat them. No, this is not working out. And finally the guy's like, oh, I was just kidding. Not really true. They detracted that paper, but it's done so much damage. It's done so much damage, y'all. I mean, people, you don't know how many kids have gotten the measles and things like that. I'm sure there have been deaths as a result of that. That guy's irresponsible moves. There's a lot of stories about this. A group I think it was in North Korea, said that they had cloned human beings. People go to the method section. You have to be able to validate somebody else's research through repeatability, and that comes in the method section. Again, what level of detail? How much detail to put there? You just always keep returning back to this. Does somebody need to know that detail in order for them to repeat your experiment? If they don't need to know it, don't put it in there. Right? It's philosophically speaking, it's a relatively easy section to write, just because you're guided by that principle. Okay, I'll give you some more detail. The results is what you found. And for me, and in this class, and in my experience writing scientific papers, this sort of has two components. It has a graph or a table, but in this class we're going to have a graph, and it has a narrative. There's going to be some graphical representation of what you found, and then a written description of what you found. Method sections are generally pretty short, especially in here, right? And what are you gonna, in terms of what you want to report here, it goes back to what did you predict? What was your prediction about your results based on your hypothesis? What did you expect to see? Well, this tells you what did you see, okay? Before you collect any data, you want to tell the researcher, this is, if I'm right, this is what we'll see. Here we say, well, what did we see? Here we say, okay, we bring it all together. What do our results tell us about our hypothesis? Okay, what's our answer? All said and done, we get our results in, And are we getting closer to the truth here? What is my answer? Here, we're not interpreting, we're not really laying any meaning onto the numbers, we're just telling what the numbers were. Here, we're sort of interpreting our results. And we are, especially in light of our hypothesis. Okay, so we're going to start with that. And then there's a couple other things that have to happen here. Is we are going to discuss limitations of our study. And that tells us what's our confidence in our answer. The only time I've ever gotten in big trouble, like I'll get papers rejected outright, is if I'm trying to be overconfident with my data. If I'm trying to say something that I really have no leg to stand on. As long as you tell the reviewers, like, I think basically what you don't want to do is say, like, I went from here all the way to here, when actually you just went to there. If you tell the reviewers, you know what, I don't have real strong data, here's some limitations, I think that I moved the ball forward a little bit, they usually say, okay, that's a contribution. It's when you say, like, I used 10 cameras over the course of a month in one place in Cherokee County, and now I know everything about whether logs can predict wildlife use. Right? So that's where we have to be humble. That's where our humility creeps in. And then we are going to set the stage for the next researcher, for next researchers, right? Again, it's intentional. We know that somebody else is going to come along and want to pick up from here and get closer to the truth. We're going to give them, based on all the work we've done, we're going to give them some insight. I think here's my answer, but there's issues with the answer, and here's the ways to deal with those issues. Okay? It works really well. We pick up where somebody left off, and at the end we say, here you go. And when I'm starting a new research project, I'm opening up papers, I'm going to the discussion, and I'm looking for comments there. They'll say things like, this is a fruitful area for future research, or something like that. Right? This is I just love this, it's a really elegant process. Okay? And that's what you're going to do in this your lab report. I'm going to have, pretty much done. I'm going to post it a few pages, written description of the lab report. It will have prompts for a lot of this stuff. Like in the intro, this is what I'm looking for. There's a rubric that tells you what I'm looking for in your lab report. This experiment or this little presentation will help you. I really want you to do well on this assignment, and so I'm trying to provide you with some good research, good resources. This we've pretty much just gone over. Right? What's your question? Why is it important? What's currently known? What's your hypothesis? And you also want to provide what the evidence and logic is. So you don't want to just provide your hypothesis. You want to say, I think that this will be the answer because this. Oftentimes we do use a citation here. Here we're definitely going to use a lot of citations. It's like a mini literature review about this topic, about the question. This one, right, I think this is important, really important, because you guys ever watch those ghost hunter shows where they like go into I'm sure so many in Savannah. You're like going to the Ground Central. Yeah. To ghost hunting. But would you, as a scientist, what's the issue with those shows, with these investigations? How's this go? They go in there, they go into the house, And did they ever not find evidence?
They always find something.
Because why?
It's fake.
Oh, because it's fake. Oh. Well, that's arguable. No. Because whatever happens, it's evidence that there's a ghost there, right? If the floor creaks, that's because it's a ghost. If the guy next to him, his eye starts twitching, why? Because it's a ghost, right? You can't look for meaning in every single thing, right? You have to say, okay, before I get started on this, this is the clear evidence that suggests that my hypothesis is supported, okay? Otherwise, it's just too tempting to retroactively look back and say, see, right there, this is evidence for my hypothesis. You've got to do it before you get started, right? You do that, not de facto, but whatever, pre-facto, beforehand, okay? So in our experiment, this is what I see as to be our, and I'll post this too. This is what I see our research question shaping up to be, right? The top is sort of like the nerdy version of it, really succinct. Right? Can the characteristics of a log predict how many animals will use it to cross a creek? Which basically says, if I tell you of a log, I say, here's the diameter, here's the height, here's the depth of the water. Can you tell me, can you put this into get your slide rule out, a calculator? I think that within a month, 27 animals will cross it. That's kind of what we're trying to do here. Okay. So that's our research question. Okay. That's our research question. The why, who cares about that? Again, important question. This is my own take on this. This is what I see as shaping up to be a good impetus. I have been doing work out there at Dr. Flint's for probably 5 years. I'm really excited about having a list. That's what the Bioblitz is about too. A list of all the species that occur at Dr. Flint's. I would love to know where they occur, how many there are, how many males, females, population levels, because this area is changing quickly, and Dr. Flint's farm will be there in 100 years, same state, because he has it under an easement where it can't be developed. Imagine if I hand to somebody, or 100 years from now, they have access to know they have a snapshot of what the populations were in 2021, and then in 100 years, that'd be cool. Imagine what we knew, if we knew what was here 100 years ago. There would be passenger pigeons, there would be Carolina parakeets. 200 years ago, there were probably elk, there were probably wolves, mountain lions right here on this campus, right? But there's no data. People were not collecting that data then. I want to collect that data for the future. So one of the really important ways to collect that data is proving to be these remote cameras, right? Here's a really cool animal that we know so little about, right? Snow leopard. Why? They live in the middle of nowhere. They're very, very wary. You're not going to sneak up on the snow leopard, right? But putting these remote cameras out, they've got a lot of insights. They can tell that this is whatever, female number 27.3 because she has 4 dots on her leg, and they can tell behaviors, all kinds of neat stuff. But how do you place the camera? Where do you put it? Do you put it next to a rock? Do you put it on a log crossing the creek? Right? So to me, that I can make a good justification for our research, because understanding the effective camera placement is critical. And there is research on this, right? This is not a new thing. People have looked at, do I put it on a game trail? Do I put it in random? Do I put it on a log and put it in a random spot? How does that impact what we know about human or wildlife populations? So that's for me. Now you guys can use your own brain and come up with whatever you want to for impetus. There's other things I can think of that would be interesting reasons to do this research. But I'm providing you a little bit of ideas here. Hypothesis. I want you guys to come up with a hypothesis, but there's not really that many different hypotheses here, right? It's either basically, I think you can use your brain, again, thinking about what you know about logs, and we had this discussion in here about what do you think would be a good log. And we said large diameter. We said if it was over a deep part of the creek, they might be more likely to use the log instead of wade through the water, right? Based on all this stuff, come up with an answer to can we predict animal use or can't we? Right? There is no, this is not a test where I'm going to say, you said that we can't predict and I'm going to mark you wrong. There's no right answer. It's a thought process. Providing your reasoning. There is no right answer. I hope you can hear me saying that. It's like a lot of this stuff people are uncomfortable with because they just want a formula to come up with an answer. This is using your brain. Do you think that we can predict animal crossings or not, right? And if we can predict animal crossings, then we should be able to use the characteristics of the log, and that will correlate with the number of animals that cross the log. This is our prediction, okay? This is pointing to what our results will be. And I'm going to talk about this in a second. Methods, again, a lot of this detail, I don't expect you to know a lot about the Flint farm, all this stuff. I'm going to provide a lot of these details for you to include in your method section, okay? Here's where we did the research. And we had the two groups, so some of you went to one place, some went to the other. Trying to think. So I know Summer, you set, and you and Jacob set this one here. This is that wet, muddy, and Angela too. Remember we had to there was the harrowing,
The barbed wire.
land mines and stuff.
Yeah.
We're pretty much heroes. That's that one. And I think, Shelby, you guys were working on this one down here.
Oh, yeah, across the.
We went down the power lines. Cows attack here. You guys went down here, we went there. And then some of the other group, we went down a road along the creek, and there was the big fields. Those are those ones here. Okay, so I'll provide this map for you. And now, here are those, we have 10 logs total. There's number 1, number 2. Each of them, and what we did, we took the measurements on the diameter, the depth, right? To me, this one's pretty sweet. Here you go. Thick log, low to the water, deep water. If I'm gonna either try to swim through this or walk over a bridge, it's a no-brainer, right? But of course, we need to have some differences. That one's pretty nice too. That one looks pretty slick, tiny little log, pretty high off the water. I don't know that I'd take my chances on that. But then again, that's through human eyes, right? This one's like, if I was standing here and people like this, the jumper's like 10 feet off the water, right? But maybe a squirrel doesn't care, you know? That goes, again, that's your reasoning about what do you think is going to be the result here? Okay, so here's all of our different logs. We'll provide you, I think that's, okay. Now let me just show you as a motivator. Here are some of the results. That's yours, Shelby. That was probably one of the best logs. And not just yours, I think Marie was there too. Look at that. It's clearly crossing right over the creek. Now, so not every...
Is that a doll?
Yes.
Oh.
That's Oscar. You know Oscar.
You?
Carlos's dog, the little blonde dog.
Oh, yeah.
There's a little, let's check out the little armadillo. That's a new species that we have not seen here in the last, except for the last 5 years or so.
Fell.
Say, like, this one, this guy is like every night, same time, he's like punching in for work. Gonna go eat dead stuff off the road. Doo, doo, doo. Oh, look at the bobcat. Check out these guys. Yep. They're on the log, and they're like having a gladiator battle here. Now, what do you do with this? This big buck scraping on this, is he crossing the log?
No, the one's crossing the water.
Also not using the log, right?
I want to see a deer trying to cross the water.
So I'm gonna give you a bunch of videos, and you have to make the call. Is this count as an animal crossing the creek on the log? This one, clearly yes.
So what about the ones that weren't crossing the water?
That's up to you.
The armadillo that fell in the water.
There's not, everybody's lab report is gonna be different, right? It is inconceivable that you guys would have the same, look at him, he's like, what is this thing? You'll see on one of the cameras got knocked over, and then the cows are just like looking at it constantly. Look at this bobcat, guys, check this out. I've never seen a close-up of a bobcat like that. Here, does this count as 2? Pileated woodpecker. Again, I don't think he's crossing the log, but it's a cool video.
Okay.
Check, this is just beautiful. So many pictures. Look at that guy, he's just probably looking for crayfish in the creek. Look at that one, he's got something wrong with his leg. Night shift. So there's gonna be some subjectivity in this. This is the most amazing video I've ever got.
Wow.
A mama bobcat with 2 little kittens. She gets up there, stops, turns around, checks on her babies.
Was that the same one that's right there?
Yep. Look at him, he just books it right down there. He's clearly crossing the creek. And this guy's coming from the other direction. He's like full throttle. And then this is our parting shot. Doop. So I'm really excited. I think that we got a lot more videos than I really expected to get. Right? And so what you end up with, oh, let me pull that up. I will provide you this. Log 1 through 10. There's the data you guys collected. Here's where the logs were. Here's when we started the camera. This is just for me, where I'm keeping track of which one. And I'm going to provide you this crossing score. This crossing score is a combination, a function of these variables. I wanted there to be one number that we can use to summarize the attractiveness or the usefulness of that log as a bridge. Okay, and the way it works is just a function of it is, and this is again I'll describe for you. It's I think it's diameter plus height minus diameter plus depth minus the height. So as the log increases in size and the depth of water increases underneath it, then the score goes up, and as the height above the water goes up, the score goes down. Okay? And so you can kind of play around with it. you can look and see which one of these looks pretty poor. Well, we've got this one has a really small diameter, which would be pretty hard to cross. It is very high off of the water. Well, actually, it's not that high compared to these others. This one's small diameter, high off the water, and the water is shallow underneath, right? And if we look, it has a very low score. This one has a high score. It's wide, not real high off the water, and deep underneath. So we have some variability there, okay? And what you're gonna do then is you're gonna make another column and you're gonna go through the videos and put the number of animals crossing that log, okay, during that time period. You're gonna put the number of animals crossing during that log. And then what you're after to answer our question, this is where statistics comes in. You guys, most of you guys have probably taken statistics at this point, right?
Mm-hmm.
It's one of those things, it's a pet peeve of mine, that you guys take stats. I'm gonna turn the slide on here. And then it's like there's no connection to biology. Statistics helps us to answer questions, okay? It's a very important skill, and we're going to use statistics in an applied sense in this laboratory, okay? Because this is what you'll end up with. You're going to have, for a given log, we'll say, okay, this log has a low crossing score, and there's not a lot of animals using it. This one has a pretty high crossing score, but still not a lot of animals. Or no way, has a lot of animals crossing, but a pretty low crossing score, okay? What we want to know is, are the two related? Okay? We want to know, are the two related? So if this is your data set, what do you guys think? In a just opinion, subjective, purely subjective fashion. Going back to our research question is, if I tell you the characteristics of a log, can you tell me how many animals will cross it? Here's your data, what's your answer? Is this a random pattern, or is there a pattern here, a biological pattern that suggests that the characteristics can predict the animal crossings? What do you think? How many people look at this and say, I see a pattern here? Raise your hand. Okay. So a couple people. Okay. What about this one? How many people look at this and see pattern? Okay, so much higher confidence. How about this one? Okay, so see, there's opinion in this. That's what we want to avoid. What statistics does is it gives us an objective probability. It gives us a probability that what we're seeing is an actual pattern. Okay, that's the usefulness of statistics. I'll give you a couple of examples here. And again, I appreciate you guys hanging on here because this is a lot of stuff for one, but we're getting real close to being done here. Do you remember in stats, you guys talked about p-values? And I'm recording this, so you can go back and watch it if you want. And I told you, I promised you guys this is going to be really exciting. Didn't I, Emily? Make it worth your while, or 2 hours of sleep. Okay, so what you'll end up with, and I'll show you guys how to calculate a p-value, but what you're going to end up with that tells you your answer is this p-value. They range from 0 to 1, and the magic cutoff here is this. P-value, think about this, is your probability of crying wolf. Okay, and what does it mean when you cry wolf? You remember this little boy? I don't know why my mom used to use this a lot. I must have been like one of those crying wolf kind of guys. What is the crying wolf?
I mean, you like say you found one, but you didn't really.
Okay, so you say there's a wolf coming, but there's not a wolf coming. Maybe I'll have detention, I don't know. This would be saying that there's a pattern, but there's not actually a pattern, right? So with this one, there was a lot of subjectivity. We weren't sure. Some people said there was, some people said there wasn't. And again, that's probably personality. Some people see patterns, some people don't. This number gives us that number. It tells us that, so if we say that there is a pattern, then we're going to be wrong more than 10% of the time. Right? That's how to interpret this number. 0.10 is 10%. And we will cry wolf 10% of the time. That's not acceptable, right? I'm not comfortable to be, so basically what we're saying is we're going to be wrong more than 10% of the time. So we're less than 90% confident in saying there's a pattern, okay? That's not, so if these are your data, there is no, then the answer is we cannot predict number of animal crossings with log characteristics. If it look like this, our p-value is less than 0.001. And what does that mean? So, yeah, we're gonna, if we say there's a pattern, there's still a chance we're wrong, but the chance is very, very low. So therefore, we feel confident to say that there is a difference, okay? And then we ended with this one. This one, again, to me, like this is kind of obvious. I don't see a pattern. This one is obvious. There's definitely a pattern. It's these ones that are the ones that are confusing. This is where statistics comes in. We don't have to make an opinion-based guess. We calculate the probability. We say that it's less than 0.05. We're comfortable to say there's a pattern. Therefore, yes, log crossing score can predict the number of animals crossing. Okay. I don't know what the data are going to be. You will have your data, you'll have your crossing score, you'll calculate your p-value, that's your answer. Okay. Your discussion, right? Again, we got our p-value, so we answer the question. Yes or no? Can we predict animal crossings? Right? But again, it's never that simple. What are the issues of our experiment? What are some limitations that we have? We can talk a little bit about the so what behind your answer. We're going to compare what we found to other researchers, and then we're going to go that next step of what would the next experiment be. Okay? This is the creativity part. There's no right or wrong answer. The only wrong answer is a one-word answer that we use more cameras. Well, yeah, I mean, sort of course. What could you do to get a really much more confident answer in this? Right? It's where you have to think about science and experiments and data and all that stuff. Those are set up. How would you do this differently? How could you do this differently? Could you experimentally do this? Could you control? If I see more animals crossing this log, if we had that same exact log, and it was here and one was there, do you expect there would be differences? If you had same diameter, same depth of water, same height above the water, and say all 10 of those cameras had the exact same log crossing score, would you expect to see differences in how many animals crossed them? Why? What are some other variables that we're not measuring that affect how many animals cross the log?
Like the animals that are living there, or how exactly that habitat is set up? So
this one's in the middle of a field. This one's in the middle of a forest. Look at these ones. They're square in the middle of a forest. Is that going to affect? Could you control that?
Yeah.
Could you only put them out here? Could you actually cut down the trees and lay them more to say, you know, I mean, look at these logs. It's pretty straight shot. Have all these weird branches and stuff. Some of them, look at this one. I mean, you guys did the best you could, but which are you measuring? This, you're measuring that? Is it this height? You know what I mean? There's so many different variables. It's a very crude answer that we have. How could you get a better experiment, a better study to answer the question? The sky's the limit, right? That's where you end your experiment. This would be a really neat experiment to go and continue with and to go and present. You could probably publish this, you know? But this is the iterative process. The next group that comes along, they're going to be standing on your shoulders. How do you help them with that? So that is, you know, in a nutshell, where we're going to go from here. I will provide those, all the videos within the next week or so. I'm going to have the write-up here that will have a lot of this information. I'm going to have an example lab report up there just to show you the kind of scale of what I'm looking for. Not to copy, of course. It's on a totally different research question, but it should give you some idea. This is should not be well, it's one of the tougher assignments in the class, but, you know, it's one of the more important ones. Learning to write will never hurt you, right? It's more important than learning that a leech is in the bottom and lid, frankly. So, all right, thanks guys. And we'll see you next week.